All right, so go ahead and try to guess what we're going to do. Give up? You're not even answering. Okay, so we are going to solve quadratic equations. We've already solved some that were in vertex form. I don't know if you remember it. It was like, I think we were just finding x-intercepts. We might have called them equations. I don't remember. It's the same thing. But it was like 2 parentheses x plus 5 squared minus 98, that kind of stuff. We've solved equations like this where y was equal to 0. Now it's in standard form, and this is one way. Now I'm going to show you one way that you can solve these, and it involves factoring. Oh my gosh, you're so lucky. All right, what we're going to do is we're going to factor this quadratic, okay? I'll show you why it's called the zero product property here in a sec. So two numbers that multiply to 20, and they add up to give you 9. X and x to give you x squared, it's got to be a 4 and a 5. They multiply to 20, and they add up to 9. Now they're the same signs, and they both have to be negative. So negative and negative. Now, you can already tell me, I'm sure you know what they are. There's two answers here for what x has to equal. This is called the zero product property, is what we're using, and it's a way of solving quadratic equations. Basically, since we know that this is multiplication, we know that x, in order for it to equal 0, we know that x has to either equal 4, 4 minus 4 equals 0, or x could equal 5. Those are our two possible solutions for this original equation. So the reason that we're able to say this is because it's multiplication. Basically, if you have two things, two numbers, if they multiply to give you 0, well, then one of them has to equal 0. All right, that's called the zero product property. All right, in this case, we had this stuff times this stuff equals 0. Well, that means that either this has to equal 0 somehow, or that one has to equal 0 somehow. Okay. Let's do another one real quick. We're going to try to factor the quadratic first. So two numbers that multiply to 21, and they add up to give you 10. Multiply to 21 and add up to 10. It's 3 and 7. All right, they were the same signs because it was plus, and they were both plus signs. All right, now, in order for the two factors, or one of the factors, to equal 0, this one, x would have to equal negative 3, or for this one, x could equal negative 7. Those are our two answers to this original equation. Negative 3 plus 3 gives you 0, and 0 times whatever this is will ultimately give you 0. We got time. This one's going to be different signs because it's a negative. Try to factor it real quick. Two numbers that multiply to give you 5, and they subtract to give you 4. Well, it's got to be a 1 and a 5. The order doesn't matter here, but the signs do. It's different signs, and the bigger number has to be positive. So the 5 has to be positive, and the 1 has to be negative. All right, and then for your answers, well, x could either equal 1. That way this would equal 0, and so the whole thing's 0. Or x could equal negative 5. You get two possible answers. Okay? I guess like if you were actually to take a step back, I don't know if we're doing this later or not, but if you were finding the x-intercept of this, you remember a long time ago we found the vertex and we graphed these? I don't know what it looks like, but it looks something like this. If you wanted to find the x-intercepts, this is how you would do it. It would be 1 for that one and -5 for this one right here. Okay, you plug in 0 for y, and that's what you get. You get an equation where the right side's equal to 0. I don't remember if we're going to do more of that later. So anyway, for this one, because this is an equation, all right, I notice that 3 goes into all those, but because this is an equation, we don't actually have to factor out a 3 like we have before, where we put the 3 on the outside and then fill in the blanks. Because it's an equation, we can just divide everything by 3. All right, like divide the left side by 3 and then divide the right side by 3. And you're still going to have an equivalent statement. 72 divided by 3 is 24. And 0 divided by 3 is still 0. Yeah, because we're not just factoring, we're actually solving an equation, we can do that. We can just forget the 3. Now, find two numbers that multiply to 24 and subtract to give you 2. Let's see, 2 and 12, 3 and 8, 6 and 4. There we go. They are different signs because that's a negative, so 1 plus 1 minus, and the bigger number has to be negative. 6 has to be negative. 4 has to be positive. And so our two answers, x could equal 6, or x could equal -4. Those are the two numbers that you can plug in for x to get 0. Good.